Okay, hello. So we're now on our last discussion for the final, so which is about the multiple linear regression. If we could still recall, okay, so for linear regression, so is dependent to a single variable. Okay, so one independent variable. So meaning the dependent variable is only dependent on a single independent variable. So like for example, so if let's say your grade, okay, so depends only on the IQ of the students. So therefore our dependent variable is your grade, and then the independent variable so will be the IQ of the students. But then there are cases that if we want to predict, so what would be your future grade? Okay, so what would be your future grade? So based on the given independent variable, so let's say the grade is not only dependent on the IQ of the student, so rather it's also dependent on the number of hours spent by the student in studying. Okay, so that is possible that it will be a second independent variable, or possible that the your grade, okay, so would depend on the quality of instruction that was provided to you by your instructor. So that's another variable to be considered. So if whenever there are multiple independent variables, so where in the dependent variable is dependent into, then that is the time that we use the multiple integration. So as you can see on the give on this one, so if we are given multiple independent variables, so we can represent that one into the linear regression. Okay, the linear regression equivalent for that one, so the best fit line, so would be an equation of y is equals to a sub 0 plus a sub 1, so times x sub 1, and then plus a sub 2 times x sub 2. And this one, that would be the error or the residual error. But then, so if this is only dependent to two variables, so we are representing that one as x sub 1 and x sub 2. So x sub 1 and x sub 2 would represent the independent variable. So graphically, this is how it looks like. So it would serve as a plane. Okay, so if it concerns of two independent variable. But then again, so multiple linear regression so can be more than one or even more than two independent variables. So by the way, so how do we find the a sub 0, a sub 1, and a sub 2? So to represent, okay, so the equivalent regression line, okay, or the regression equation, so for the given data sets. So we can do that one. So similar with the derivation, okay, so the derivation of a formula so that we use for polynomial regression, it's the same thing. Okay, so we get the coefficient or the variable. Okay, so for the given coefficient, so we start with n, and then the summation of x sub 1 times I, x sub 2 times I. And then as you can see here, so we just repeat. Okay, so if you're going to take a look at the pattern, so there's a pattern. So if this is x sub I, this is x sub I as well. And then if the third row or the third column is x sub 2i, so the third row is x sub 2i as well. But then, so whenever we get the diagonal term, so that is actually the product. Okay, so this one is x sub 1i, so times x sub 1i, so that's why we have the x sub 1i squared. And then, so same as true with this one, this is x sub 2, x sub 2i, so that's why we have x sub 2i squared. And then, so to get this one, so that is the product of the x sub 1 and x sub 2, so that's why we have x sub 1i, x sub 2i. So if you want to get the term for this one, so we multiply the x sub 2i and the x sub 1i. Okay, so that's how we form the given matrix. So in solving for the values of a sub 0, a sub 1, and a sub 2. And then this one, so would just be the summation of the y sub I. And then the next is the independent variable x sub I, multiply it with x sub I. And then the second independent variable, multiply it with y sub I. So this is for two independent variables. But then again, So if we have three independent variables, so we can make it, okay, so for three independent variables, so that would become, so y is equals to a sub 0, so plus a sub 1 x sub 1 plus a sub 2 x sub 2, then plus a sub 3 x sub 3. Okay, so plus the error. But usually, so we don't consider that anymore. Although we can compute for the correlation coefficient, okay, so which is dependent on the residual error for the given regression line. So how do we form the matrix? So if it is three independent variables, actually we have here, if this one is for n independent variables. So as I have mentioned, so let's say in this case, so there are n independent variables. So for the first row, so we just start with n. Okay, and then this is x sub 1i, x sub 2, x sub 3, up to x sub n sub I. Okay, so same as true with this one. This is x sub 1i, 2i, 3i, and up to xni. And then for the diagonals, as I mentioned, so to get this one, so it's just a product of x sub 1 and x sub 1. So that's why we have x sub 1 squared. So x sub 2 is x sub 2i, x sub 2. This is x sub 3, x sub 3, and x sub 3. So to get the this one, so this one is a product of x sub 2i and x sub 1i. So this one is the same as true. So this is x sub 2i, x sub 1i. So this is 3i and 1i. And then, so for this one, so it's a combination of this and this one. So it's just a product, okay, so of the row and the column. So this is on the second row, third, okay, x sub 2 and then x sub 3, x sub 2, x sub 3, and so on. So for this one, so we just start with y sub I, and then we multiply it with the first independent variable, the second, the third, up to the nth independent variable. Okay. So by the way, so this should be, so this should be x sub n sub I and then y sub I. Okay, so it's not cubed or squared. So that's how we do it for multiple linear regression. So let's have our example. So use multiple regression to fit this line. And so let's try to find as well and compute for R, okay, or the correlation coefficient. So we have two independent variables here, so x sub 1 and x sub 2, and we have the dependent variable y. So we have how many data sets? So 2, 4, 6. So there are 6 data sets. So we want to find, so what is y is equals to a sub o plus a sub 1 x sub 1 plus a sub 2 x sub 2. So we just need to find what is a sub o, a sub 1, and a sub 2. And then later on, so we compute for r, so to find the correlation coefficient. Okay, so to make our computation easier, so I'll be using a spreadsheet. So I already encoded the given, so 0 to so let me check. So 0 to 2.5147, 0, 1, 2, 3, 6, 2, so 5, 10, 9, 0, 3, 27. And as I've mentioned, so to compute, so for a sub 0, a sub 1, and a sub 2, so what I want, so would be the n, and then so I'll have the summation of x sub 1i, and then the summation of x sub 2i. So the same as true with this one. So I'll have the summation of x sub 1i and summation of x sub 2i. So in here, so that would be the x sub 1i square. So this one is the x sub 2i square. So this one, so would be the product of x sub 1i times x sub 2i, and then this one is the same, so x sub 1i x sub 2i. And then so this given matrix, so would be equal to a sub 0, a sub 1, and a sub 2, and so that would be equal to the summation of y sub I. So the next one is x sub I, y sub I. And then the summation of, or x sub 1I, then x sub 2I, y sub I. So these are the variables that we need so to compute for a sub 0, a sub 1, and a sub 2. So to do that, so I'll do the Excel. So I already have the x sub 1. Okay, so we have the x sub 1I, x sub 2I, and y. So I need to find, so the product of x sub 1I and x sub 2I, then the square of x sub 1I and the square of x sub 2I. So what I don't have here, so I think, so what I need would be the product of x sub 1I, so times y I. Then the other one, so what will be the okay, should be 11 x sub 2 I y I. Okay, so we need to find the product first of x sub 1I and x sub 2I. So we just simply enter our equation, so which will be equal to this one, and we multiply it. Okay, so where is it? So we multiply it with c sub 2. That would give us a 0. And I don't know how to use this one. Okay. So we copy the formula. Okay, so 2, 1, and 5. So that's correct. So the next one is we square. Okay, so this would be equal to, so we square x sub 1. So we raise it to 2. Okay. And then this one, so we raise it to 2 as well for x sub, so this one is x sub 1, so the other one is x sub 2. So that will be equal to, then raise it to 2. So next, so it's a product of x sub 1. So we multiply it with y. Then the other one is x sub 2. So we multiply it with y as well. So that's the first thing that we need. Just going to copy it and paste it. Okay. So just to check, so x1 squared is 2, so x2 is 1 squared, so 2 times 1, oh sorry, Yeah, 2 times 10 is 20, 1 times 10 is 10. Okay, so that's correct. So afterwards, so we get the sum. Okay, so the sum, so for x sub 1I is that one. Okay, and I need to copy it. And paste it to. Okay, so we were now able to complete everything. So n here, so 2, 4, 6. So there are 6. And then the mean. I guess I need the mean for y. Okay, so for y, so that will be equal to, so the y, so we divide it by 6. So which is 9. Do I need to get, so I don't need to get the x sub 1 in it. Or if we want, the 8. Okay, so we now have the mean for y. So now is we want to create. Okay, so we want to create our matrix. So we start with n. So n here is this one. So which is, sorry. So I'll start here. So which is equals to, so it's equals to 6. And then what I want, so would be the summation of x sub I, so which is equal to, so this is the summation of x sub I, correct? Then for the next one, so we have the summation of the x sub 2. And then, so from here, so we just copy the same thing. So this is x sub I. Then this one is x sub 2. And then this is the square of x sub I. So the square is 7625. And this one is the square of x sub 2, which is the 54. And next, so this one is the product of x sub I and x sub 1 and x sub 2. So which is the 48. So we copy the same thing here. Export. This is equal to 54. Okay. So now, so this one is the y sub I. Okay, so remember, so this is what we've done so far. So this given matrix is done. So we proceed with y sub I, then the summation of x sub I, y sub I, and x sub 2, y sub I. So for the y sub I, so the summation is the 27. So which is the 54. Y sub I. Oh. So this is equal to y sub I. And then this one is the product of x sub 1 and y sub I. X sub 1 and y sub I is 243. Then this one is the 100. Okay, so we now have our given matrix. So we're just going to solve this one. So using Gaussian elimination. Okay, so we can do that. So by first, okay, so transforming the first row, okay, so into 1. Okay, so we can do that by dividing everything, okay, so this row by 6, or by itself. However, so I'm attaching a dollar sign there so that B12 will not change, okay, because I need to divide everything by 6. Okay. So once okay, I need to copy this one. Okay, so I'm having a hard time. Should be 12. Well, I got that one. Okay, I think this is the copy. I'm sorry, it's not. So where's the copy button? Okay, there it is. Okay. And then afterwards, so I need to make this equal to 0. So therefore, so I'll make that one as the second row. So minus the second row but then so I need to fix the 16.5. Sorry. So we multiply it with the row, first row. Okay, so that makes it 0. Okay. So the next one, so the same is true with this. So we equate this one to 14, and then minus the same as true, but then so I need to fix that one. Multiplied it with the first row here. So the next thing is, so we change this one into 1. Okay. So to change that one into 1, so we equate this one to this, and then we divide it by itself. Then again, so I need to fix that. So we copy, paste it, and we paste it there. Then afterwards, so we want this one to be equal to 0. So to do that, so that would be equal to the same row. Then we subtract the same row, but we fix, so 2.75, so to be constant, and then we multiply it with our pivot point, our pivot element. And return. So that is 0. Double. Okay. So we're going to do the same thing. So for the third row, so that will be equal to the third row. So minus the same element, but we fix it. Okay, so it changes. So it should be the same. Okay. And lastly, so we divide this one by itself. Then, so we make that then we transform this one. Okay, so we start at the top, so to be equal to 0. So this one minus the same as true. So we fix. So we multiply it with our pivot element. And finally, And there we have it. Okay. So 5 will serve as our A sub O. So 4 will serve as our A sub 1. And lastly, so this one will serve as our A sub 2. So we can now form, okay, so based on our computation, so we can form so I can copy this one. So I'll capture this. Then the other one. Okay, so the first table, okay, so is to formulate the necessary variable. And then for the second table, so that is using Gauss-Jordan elimination. So we were able to formulate that y is equals to 5. And then a sub 1 is 4. So that is 4 x sub 1. And then minus 3 x sub 2. So that is our y. Okay, so that is the linear regression. Okay, so that would represent those multiple variable. But then if we are going to compute for the R, okay, or the coefficient of, or the correlation coefficient, so we need to find first the coefficient of determination, so R squared. So that is the residual. So using the mean, okay, for y, and then the residual, so using the mean for regression line, the residual from the regression line over ST. So to find for S sub t and S sub r, okay, so we can find that one, so by getting this. So S sub t, okay, so this will be our ST. And this would be our SR. So ST, that's the residual, that's the difference between that of the data point y, so minus that of the mean value for y. So that means what would be the error so between the data points in comparison to the mean line. While the other one, so we have y minus a sub o minus a sub 1 x sub 1 minus a sub 2 x sub 2 square. So this time around, so that one corresponds to the residual. Okay, so the difference between the actual data points to the regression line. So we can find y minus y bar. So by using, so our y is, so we wait, so equal, so this is 5, or sorry, so we need to square it. So that would be this one, and then minus our mean. So we computed for mean, so which is the 9, this one, the mean for y. But then, so we need to fix so that it won't change. So that is why, so I'm going to add a dollar sign there. Okay, so we have the 6 data points, 2, 4, 6. I think there's something wrong. Okay, so it should be raised to 2. Okay, so we have 458, so for ST. And then for our SR, so this is a bit longer. So that will be equal to, so we start with y sub I, so which is the 5, then minus the product of a sub o. A sub o is, I'm just going to type 5, so that's 5. We have a 5, a 4, and a negative 3. So 5 minus 5, okay, so it's just a sub o minus 5, and then minus the product of 4 times x sub 1. X sub 1 is that one. And then lastly, so minus, it's a negative 3, so for a sub 2, so multiplied it with x sub 2. Okay, so y minus a sub o minus a sub 1 x sub 1, so minus a sub 2 x sub 2, and then we square the final answer. I think there's something wrong. So y, can I check it? So y is 5, a sub o is 5. So 5 minus 5 is 0. X sub 1 and x sub 2 are both 0, so therefore that will be 0. About this one. So y is 10 minus 5 is 5. And then a sub 1 is 4. 8. So is 8. 5 minus 8 is negative 3. Okay. So I guess the answer there would be 0. Okay. So from here, so we have, I think, based on this problem, these data sets were just taken from a real line. Okay, so that is why, as you will see, so if we have an ST of 458, so if ST is 458, and then our residual from the regression line is 0, so that means the data points are a perfect fit on the regression line. So therefore, we have a coefficient of determination, so which is 458 minus 0 all over 458, so which is equal to 1. And our R would be a relation coefficient, or coefficient of correlation coefficient, so which is equal to 1. Okay, so that's how we get, okay, so the regression line, so using multiple regression. Okay, so take note that again, so the multiple regression is not limited to 2 independent variables, so we could have more. So if we have more, so we follow the format. Okay, so for multiple linear regression, so with an independent variable. Okay, so that will be all. Good day.